This lecture is about mathematics and numeracy development in an inclusive classroom. We'll be thinking about why they are different things, mathematics and numeracy, and why it matters. Then we'll think about helping students with their numeracy development, and then helping learners with their mathematics development. And then we'll look at one usual approach, which is streaming, which is an intervention that we know doesn't work. So what is numeracy? Well, we can go into a great deal of detail about this, and there's a whole area of study which we'll just numeracy it has many definitions, but this was an early definition from the Australian Association of Mathematics Teachers. It was about the willingness, the disposition to use in context a combination of mathematics, more than number, so numerical, spatial, graphical, statistical and algebraic, mathematical thinking, general thinking, and a grounded appreciation of context. So that means knowing what you need to know in the context. Is it okay just to give an approximate answer, or do you need the exact result? From 2009, it became established in the Australian curriculum as a general capability and distinct from the learning area of mathematics. And then there's a continuing development of the concept, and in other courses you'll be learning more about that. So according to AAMT, to be numerate is to use mathematics effectively to meet the general demands of life. But it's that use of mathematics that really matters. It's not about mathematics itself, it's about using it in the context. So numeracy involves the disposition to use those different aspects. It's an important thing to recognise we don't teach numeracy. What we do is we teach mathematics, and then we show how to apply it in contexts, and so that leads to numeracy development. In the Australian curriculum, again we see this idea about using mathematics in a wide range of situations and using mathematical knowledge and skills purposefully. So numeracy is not the same as school mathematics, and there was a bit of a wrong approach where some schools, particularly in primary schools, were saying they had numeracy blocks and literacy blocks. Well, we teach mathematics and not numeracy, so that's been returned with the advent of the Australian curriculum. And it's certainly not the same for everyone, because it depends on what life context you're going to live in or operate in. And if you are dealing with tiling, you're going to have very different numeracy requirements to somebody who's perhaps doing foreign exchange in a bank. So you're going to be having different needs and requirements. So that's why in school we teach mathematics, so we prepare people with the underlying skills and concepts that then they learn to apply in the context where they're needed. Goose and Geiger and Benison have developed this concept further, and they've talked about these different aspects: mathematical knowledge, contexts, disposition, so your confidence and willingness, the tools of mathematics, now that's an important one, so knowing how to use your calculator, knowing how to use spreadsheets, knowing how to use measuring instruments, that's all part of numeracy. And then a critical orientation, so being able to make judgments, working out what is the use of this mathematics, not just getting the answer, but thinking about what does that mean in the context. So numeracy is a very complex area, and it's certainly not the easy stuff of maths, the basic arithmetic that unfortunately it has at times been considered. So to be numerate, you need more than arithmetic. That is not sufficient, and you need to be able to make sense of life contexts and to be able to use the available tools of maths. So when people ban kids from using calculators, we're really not allowing them to develop those skills not only to use the calculator, but when to decide when not to use it. And those things are an important part of developing numeracy. If we go now to the discipline of mathematics, so we've been thinking about numeracy, if we think about the discipline of mathematics, some people define it as that which can be proven. So proof is fundamental to mathematics. It has a variety of different ways of breaking it up in the discipline. In the Australian curriculum, it has major strands, and each of them is important for numeracy, so number alone is not enough. We'll move on now to helping learners with numeracy, and helping them in the development of numeracy. We've got to think about what they need. So we hear this term functional mathematics, and functional mathematics, what we need to function as an adult, has changed a lot. And we can see the photograph of a 1970s accountant, perhaps, who's there with an adding machine and lots of paper and pen, not a computer to be seen because they didn't exist, and certainly not desktop computers, and a pen, and away he's going. Well, in 1989 there was a list published of what people needed to function as an adult, and they needed counting, recognising numerals, telling the time and understanding quantity. But even then the authors were saying, well, actually that's really not enough. That's some content, but we've got techniques and tools that will do those things. We need much, much, much more to function as adults in an adult world. But this was it's sort of the back to the basics movement, which came around in the 70s, and it rears its head every so often that kids these days are absolutely hopeless and their teachers are at fault and their parents aren't much better. You can go back over history. I think the ancient Greeks used to despair of the youth of the day. So it's not an unfamiliar thing, but we do have to constantly be refreshing and thinking about, well, what do we need in daily life? We don't talk about functional maths. What we talk about is numeracy instead, because to be functional in adulthood is just something that we cannot determine, but we need to think about that much richer concept that we've already discussed. We need to think about, these are some of the things that I remember, but you know that I'm very old. There's a cash register that tallied up, but it certainly didn't calculate change, and it just entered the amounts. It didn't actually come up with the total. There are also bank books, and some people still have them. They're going out of style, but that was the way the bank teller would enter by hand the amount that somebody had, and you could check the amount. That's no longer what we need to do. Times have changed. We use electronic banking. Things continue to change. We've all encouraging now to be using tap and pay. So tap and pay has led to the great reduction in the amount of cash used in Australia. So our need that we have in adulthood changes all the time. Things continue to change. So instead of wasting time for learners who have difficulties in doing out-of-date things like calculating change and counting coins, what we need to be doing is focusing on other big ideas. And so we've got effective tools where if you don't want to count coins, and let's face it, who does, you can put them in a coin counter machine and put them in your bank account and then head shopping with your plastic card. So the digital age brings workarounds to people who have difficulties, and that is certainly one of the things we should no longer be wasting kids' time doing, is, except certainly in the early years we want to introduce coins and notes, but then if they're still not sure of those as moving into secondary school, we certainly don't want to be wasting kids' time. And I was watching just a year ago a Year 9 student who was being expected to learn about coins by looking at plastic token things that, to perhaps my eyes, they sort of look similar to our coins, but they were the wrong size, they felt funny because they're made out of plastic, the colour wasn't quite right, and it also seemed like such a pointless waste of time. What we need to be doing instead, if we're thinking about the idea of financial literacy in terms of money, we need some big things like, well, your money's like a bucket. Your pay goes in and your bills come out. Now, if you've got a concept of your budget, then you don't actually need numbers, but you can be thinking through, what does that mean? How do I make sure that I've got enough in my bucket to pay bills, to be able to give money to other more needy people and causes? How do I save? Those sorts of issues. We need to be thinking about FPOS. How do we manage that we don't use up all our money, just tap and go, and then run out to pay other things we need to have? So in terms of helping learners with numeracy, we really need to think about what is functional, and we use numeracy as the overarching principle and concept there, and we need to learn in context. We're going to now talk about helping learners with maths, because it's maths that underpins numeracy. And if you look at the numeracy continuum from the Australian curriculum, it's actually about mathematics skills and techniques. They've sort of distilled out ones that they think are important for use in the context of adulthood. But my contention is we don't know, and we should worry less about the numeracy continuum and much, much more about the mathematics curriculum, and then encourage, in particularly in high school, how to use those skills of mathematics in other subject areas. So helping learners with maths, we need to explicitly teach the tools of maths. We need to recognise maths is more than numbers. So if we have a learner with learning difficulties, we don't want to get them stuck there. We need to support them, but then move them on and help them to learn other areas as well. And I've got a separate little lecture around learning number facts. We're now going to think about how we encourage and challenge our learners at whatever level they're at. And doing rich tasks in mathematics is a really powerful way to do that. And there's a little bloke in year 3 in a Victorian classroom, and he was having a ball. He was loving the rich task that they were doing there. Rich tasks allow all students to make a start, and you can go in many different directions. So it's a wonderful way of doing mathematics in inclusive classrooms, because you can use the one task, but lots of kids will be able to have goes with it. They need to be open, and the tasks themselves are worthwhile activities for learning, so you learn through doing the task. And they provide a challenge at a range of levels. So you can also tick off a whole range of outcomes in the one task. So it's not, you don't go hunting for the task that matches that particular learning outcome in the curriculum. You can expect that they can cover many different areas. And there are lots of other benefits for rich tasks. So here's an example, and you can pause it and have a think about this yourself. Which numbers have an odd number of factors? Now you might be looking at that and you think, I don't know that I know what a factor is, so you might need to look that up. You might be thinking, oh, what does it mean to be odd? You can think about those, and I want you to think those. What do you need to know to be able to make a start? Well, you need to know those things, but if you think about what would be the absolute bare minimum that a learner would need to know before you could give them this task, and you could imagine that there's really not very much. They'd certainly need to know what numbers are, and they'd need to be able to work out what factors are. But how far can you go? And that's the richness of a task like this, that you can explore this task in many, many, many different ways. And once you've worked out what sort of numbers have an odd number of factors, you can then think about, well, what other types of numbers are there? What are their properties? So you can explore this task in many ways. So if you have a student who is really just getting to grips with the factors of 12, you might be wanting to get out some blocks and show them how to use the blocks to make the factors. So if we've got the factors of 12, you give them 12 blocks and you ask them to make as many different rectangles as you can. And they will probably ask, if I make a long thin rectangle of 2 by 6, is that the same or is it a different one if I make one that's short and long, so 6 by 2? And then we bring in that established fact of geometry that orientation doesn't define a shape. So a rectangle, even if you rotate it, is still going to be the same rectangle. So 2 by 6 is the same as 6 by 2. So when then we list out all of the factors, that's the side length. So we've got 1 by 12, 2 by 6, 3 by 4, and there are no others. They can try it. If you try to make one as a side length of 5, it won't make a rectangle. And so that's a visual way that kids can come up with the factors of 12. So far we've been thinking about supporting learners in mathematics. It's important to recognise that there are many different ways that learners approach learning mathematics. An example in particular is different ways that some children who grow up in Aboriginal communities have developed for learning. Robin Zevenbergen has written about this in terms she watched some young children learning how to make boomerangs, and the craftsman was there making the boomerang, but he didn't say anything. He was just doing it and just showing what he was doing. And the young people were standing around watching, and as they felt ready, they took up a boomerang and began to copy and follow along. Now I remember reading about that, and I also remember seeing a photograph of a group of young girls who were sitting in a sort of semicircle around a lady, and they were learning how to breastfeed babies. They had around their neck clay breasts because they were prepubescent, and they were just learning, just watching and thinking, and they had a doll to practice with. In our classrooms, we can think about how we might use this technique where we demonstrate and let the student join in as they want. Now, when I was working in one of these places, I was up in one of the communities, and I was assisting in a classroom, and there was a student who'd been brought in from a shopping, she'd been out down the town rather than at school, and so she was in no good mood when she was returned to school, and she was sitting doing mathletics, and she had to determine which decimal was bigger than the other, and 50% of the time you get that right by guessing, and so she just, without even paying much attention to it, just pressed a button and moved on. So I thought about the technique that I'd seen, and I just sat quietly beside her, and I said to myself pretty much, but it was really the talk out loud, and I was explaining how I would do it. And so I showed I drew a number line, and I put the numbers on, and I showed where the decimal fell, and so between which were the bigger ones. And the next one, I heard her under her breath saying, "I'll watch." And then she started just drawing and following along. And the next one, she said quite loudly and confidently, "I can do it." And for me, it was an example of how it might be done. Now, I've got some links there that you can explore, where on the EITSL website, the teacher demonstrates how she does the no language method. When I was up in the Tiwi Islands, it really intrigued me to see that they had a calendar displayed in the classroom. One of the things that makes many of us who've lived in the north of Australia roll our eyes is when people ask children how many seasons there are, and they're supposed to parrot back 4. Well, that's all very well if you live in the temperate or below latitudes. When you're up near the tropics, there's certainly many more, and you can study this one. But I just loved this around it follow January, February, and you can imagine that it'd be cyclone season. You can see the mother with the little baby holding on by hand but being blown away. I just think it's such a gorgeous portrayal. So this understanding of mathematics as having different ways and of being and doing is an important aspect. So I wanted to finish by thinking about, if we've been talking about helping learners, what can we do that we want to avoid and making a mistake? And that's in streaming. So streaming is an intervention that lots of schools use, but we know from research that it does not work. And one of the challenges is around the self-fulfilling prophecy. And if you haven't read Pygmalion in the Classroom, it's in our library. It's a short book, but it talks about a study that was done, and you can see it was 1969 when the book was published, but the study was done earlier than that, where they did a study to investigate the power of the placebo effect. Now we know in medicine that if you want to test the drug, you have to do double-blind trials, so neither the administering person or the person receiving the trial drug knows whether they're getting the real one or the placebo, because it is such a powerful effect. Now that's a physical thing that is known. Now these researchers thought, well, what must it be like in a social context? Does the placebo effect contribute to social learning? And the answer, of course, is yes, it's a powerful one. So if a learner believes, and if their teacher believes, that they are going to learn and that they are capable learners, then there is a powerful positive benefit. And if you think that you can't learn, or if your teacher thinks you can't learn, then you are going to be in a situation where your learning will be compromised. And that's exactly what happens when we stream classes. Doesn't matter if we call them the wombats or the kookaburras or whatever. If we allocate students to class by their ability or their attainment levels, we are completely acting into this self-fulfilling prophecy. They will end up where they were expected to be. So there's some really powerful research around this. There's this, I'll just go to this first, Doug and Barb Clark. They wrote a very accessible document. Now, I also had this one, you might know of Adam Spencer. He's a mathematician, but he's an ABC journalist, and he said he gave up really doing his being a research mathematician, because in a room of randomly selected people I'm a maths genius, but in a room of maths PhDs I'm as dumb as a box full of hammers. And that's the thing about in streaming, there'll always be other people that'll make you feel like you're not good enough. So some interventions, I'll leave you to pause that and go through them as slowly as you would like, but the reasons that Clark and Clark have given, and I'll also have some references for you. So we've looked at the difference between maths and numeracy. We've looked at helping learners with numeracy and then helping learners with maths, particularly both extending those learners who are gifted. We've talked about helping learners who need support. And in terms of streaming, don't do it. So think about what was interesting, what's challenging, and what you'll think more about.